Bismillahirrahmanirrahim. Assalamualaikum and hello everyone. In this video, we are going to look at how to estimate a step response with a first order plus dead time model. To estimate an open loop step response model, identify the input variable that we want to make the step change in. Next, once we have made the step change, record the output response. Once we have the output response, we can estimate the model using several ways. To estimate a first order plus dead time model, there are three possible ways that we are going to talk about in this video. First is the inflection point method, which uses only one point to estimate the first order plus dead time model. The next one is the 28%, 63% method. So this uses 2 points at the 28% and 63% of the change in the final response. Next, and the final one is the graphical method, which uses as many points as we want. The first method is the inflection point method. This method uses only one point along the step response to estimate the first order plus dead time model. At the inflection point, which is where the slope starts to change, we draw a tangent. Now, based on this tangent, we have to get the slope and the intercept where the tangent crosses over the initial value of the step response. Now, based on the value of A, which is the magnitude of the step change, and the value of B, which is the magnitude of the step response, we can calculate the process gain. So the process gain remains the same. It's the change in output over the change in input. To get the time constant, tau, it is simply the value of the step change, magnitude, divided by the slope of that tangent, which we calculated. Theta, or the dead time, is the time difference between the intercept of the tangent with the initial value of the step response and the time when the step change is made. Now, since the estimation rely on only one point, the value of our model would highly depend on where we pick that one point. So it's a little risky. Next, we have the 28%, 63% method. As the name implies, we use these 2 points to estimate theta and tau. What we have is that we know the time where the response reaches 63% of that final change and the time where the response reaches 28% of the final change. The time when the response reaches 63% is tau, and the time when the response reaches 28% is tau over 3. But since this process has dead time, we have to add dead time to it. So the response where the output is at the time of theta plus tau is equal to 63.2% of the final response, and this is the final change 1 minus 1 to the minus exponent e to the minus 1. This is from the standard step response equation for a first order model. Next, we plug in the value for when y is at theta plus tau over 3. And we know that this is where it's 0.28 of the final change. Now, we can get this value and find it on the graph. Getting the time, now we have these two information. The time at where it's 28% is actually theta plus tau over 3. The time at where it's 63% is theta plus tau. So having these two equations with two unknowns, we can easily solve for it. So this is the equation for tau, and this is the equation for theta. Now, can you try and derive this on your own? We'll talk about this in class. Finally, with the graphical method, this is simply linear regression. We know that the step response of a first order plus date time system is given in this equation. So this is the standard step response equation. Now, getting the natural log of both sides will give us this equation. Now, if we want to plot a straight line, you can plot the natural log of 1 minus y over ak versus time. So the slope is simply minus 1 over tau, and the intersection is theta over tau. We can get the time constant tau from the slope, and then from the intersection, we can also calculate for theta. So it's quite simple to do it, and with the graphical method, you can use as many points as you want to get the straight line. So this is actually the most accurate method, but it will take slightly more time and more points. Okay, so this is the slope and this is the intercept. Now, can you think, when do we use these methods? And why do we need to estimate this first order plus date time model for our step response? Think about it. We will discuss about this in class.